Hello class, and we're a very interesting situation now where I'm teaching you from my house. Looking forward to it. Alright, so today we're going to learn how to do estimations and confidence intervals. So this is a chapter on confidence intervals. Now what exactly is a confidence interval? A confidence interval is basically when you have some sort of point estimate, and remember that your point estimates are basically the estimates for the center of data. Now the most used point estimate is usually the mean, which we have been using the letter x bar to define it. So x bar, our mean, is the point estimate that we're going to be using here to construct our confidence interval. And then what you do to construct your confidence interval is you come up with a point estimate and then you add what we call a margin of error. Now, confidence intervals are basically used to explain things. Give me a second here. So confidence intervals are basically used in order to sort of explain things when you have usually sample information and then you want to say something about the population information, because you really don't have the population information, but you want to make sure that you can convey some information about it to other people. So, for example, my confidence interval can say something like, when somebody asks you a question like, well, where is the center of the data? And the answer, since you don't have population, is that you don't know. But if you have your data for a sample, you can estimate the center of the data for the population by basically creating a confidence interval. So a confidence interval is basically trying to estimate or say that my population information is somewhere within my confidence interval. Alright, now there are two basic ways to do a confidence interval. Now one way is if you know the population standard deviation. Now one way to know the population standard deviation is if you have some sort of previous study that has population standard deviation. Let's say, for example, you have a machine and you can test the machine performance for an entire hour, and then you have a sort of 1 hour population information, then you have your standard deviation. Now another way to know your population standard deviation is, let's say, for example, you conducted the census, which has the majority of the people in the US, and there's information about that. Or let's say somebody conducted some other study that has a known population standard deviation. Now, if you know your population standard deviation and you took a sample, then you can use your population standard deviation to come up with your confidence interval. And this will be the formula that we would use. And then we will be using the z-test in order to do this. The z-graph, the z-table, sorry. Now, if you don't know your population standard deviation, then we will have to use our t-table in order to come up with a value for t. Now, the value for t that we're going to come up with, if we don't know, it's going to have to use our alpha over 2. Alpha is basically how much of an error do we want to have. And it's going to be using degrees of freedom of n minus 1. Now let me try to explain a little bit more about what this alpha is and what exactly are we trying to do before we do an example for confidence intervals. So again, what we're basically trying to do with a confidence interval is we have some kind of center of data by using the sample that we collected. We have that. Now we want to say something about the population information, but we know that the population information could be anywhere around the center of our sample, because very few samples, if any, will look exactly like our population information. A sample is an estimate of where the population is. Now, what we're going to be doing with a confidence interval is we're going to be building a sort of spread around the center, that's why we're doing the plus and minus, to say something about this data. Now, we're going to need some critical values here, some numbers there, so we can say something about this information. Now, if I want, for example, to be quote-unquote 95% accurate, so if I want to be sure that I'm 95% confident, then I have to put in the center of the data, or in the center of my curve, I have to put 0.95 divided by 2. Hey, you need a calculator sometimes, especially when it's late at night. Okay, so we got to put 0.475 on this side of the data, and we got to put 0.475 on this side of the data. Now we know, if you're looking at a normal distribution, that the entire probability has to add up to 1. Therefore, whatever we don't have on the inside of the data has to be on the outside of the probability curve. So in this case, notice that we're missing, out of 1, we're missing 0.05. So we got to take 0.05 and we got to divide that by 2. That's why we call it alpha over 2, because it's a two-tail. There are two tails, two sides. So we got to take this 0.05 and divide it by 2. And that's going to give us 0.025 on each side of the data. Alright? So again, we have our 0.475, 0.475, or 0.025, and 0.025. You add up all of that, and that gives you 1. Alright? Now, the value that we need to put over here is the z value that corresponds to this on the z table. So, if you take your z table, which you're going to find where it says areas under the normal curve. So if you take your z table and you look for that probability, this probability, in the center of the table, you're going to get the z value corresponding to that. So if I go into the normal table and I look for 0.475, 0.475, right here, you're going to notice that the corresponding value in z is 1.96. Okay? 1.96. Now over here, I already wrote some shortcuts for that. So if you're calculating a 90% confidence interval, then you're going to be plugging in 1.645 for your z value. If you're calculating a 95% confidence interval, then you're going to be plugging in 1.96. And if you're calculating a 99% confidence interval, then you're going to plug in 2.58 for this z value when you know sigma. Alright, now when you don't know sigma, in order to find that particular value, what we need to do is we go to the t table. We go to the t table, and then we look at the top for the confidence interval that we want, and they have 80%, 90%, 95%, 98%, 99%, and 99.9%. And on the side, we look for degrees of freedom. Now, the degrees of freedom is equal to n minus 1. So they have to give you an n, and then you take n minus 1 to find your degrees of freedom on the table, and then you find the value inside the table when you have your degrees of freedom and your confidence interval size at the top. Alright, So let's work on an example for this. All right, so let's say that let's say that we know sigma. So let's say that you are given x bar equal to 10, and remember this is your mean from a study that you did. Now let's say that your study involved 30 people, so you have 30 sample size. Let's say that we found some kind of sigma for our study that is equal to, say, 5. All right, now notice again we're missing our z. Now how do we pick a z? Well, imagine that you want to say something about the data and you want to be 95% confident. So it's going to say something like, I want to be 95% confident, or I want to create a 95% confidence interval. Okay? Now if I want to create a 95% confidence interval, then I already know what my z is supposed to be. In this case, it's supposed to be 1.96. So what we're going to do is we're just going to plug in the numbers into this formula. And I'm going to write the formula over here so I don't lose it. So I got, alright, so if we know, we're going to put x bar plus or minus z sigma over square root of n. And then here we're going to use x bar plus or minus t s over square root of n. Alright, and again to find this t value here, we're going to be using alpha over 2, and we're going to be using degrees of freedom n minus 1. Alright, so again, the example will say something like, imagine that you did a study, you have a mean of 10, a sample size of 30, a standard deviation, actually this 5 is too large, let's put something like 1, okay? And let's say I want to find a 95% confidence interval for this information. So the way we would do it is, in this case, since we are given sigma, then we know we're going to be using this formula with z because we have been given the population standard deviation. So I'm going to be using this formula, x bar plus or minus z sigma over square root of n. And then now I plug in my numbers. So my x bar is 10 plus or minus. I know how to get the z already. Again, this is a shortcut. If it's 90%, you plug in 1.645. If it's 95%, you plug in 1.96. And if it's 99%, you plug in 2.58. So we're going to plug in this case, because it's a 95% confidence interval, we're going to plug in 1.96. And then we're going to take our sigma, which is 1, and we're going to divide that by square root of n, which is 30. Now what we're going to get is 10 plus or minus, and let's calculate that. Okay, so I got here 0.3578. All right, so now when we have this is our margin of error, this is our center of the data, in this case the mean, and then the answer to a confidence interval is two numbers. You get a low value and a high value for your confidence interval. Now the low value is going to be that 10 minus this piece of data that we have here, this margin of error. So we do 10 minus 0.3578, and we get 9.6422. And then we take that 10 and we add our margin of error, so we end up with 10.3578. Alright, now once you conducted your confidence interval, what exactly can you say about it? Well, imagine that somebody looks at this data and says, well, where is the center of the data? Where is my population mean? The answer to that question is you don't know, because you did not collect the entire population and you did not take the mean of the entire population. Instead, you took a sample of 30, and that sample of 30 gave you a mean of 10. But since you constructed a confidence interval now of 95% certainty, if somebody asks you what is the population mean, you can say something like, I don't know, but it's anywhere between, I am 95% confident that is between 9.64 and 10.3578. So it's like saying, I don't know where it is, but I know that it's between 9.64 and 10.36. So it's in between these two. The mean, the mu, it's somewhere in there, and you're 95% confident of that. All right? Now again, we just did the example for no sigma. Now imagine you don't know sigma and you want to do this again. By the way, remember, one of the advantages of having a video is that you can always pause it and then just like go back and watch it again. So if something is a little bit too fast, then go ahead and pause it and watch it again. All right, now imagine that instead we don't know sigma. So don't know our population standard deviation. You don't know your population standard deviation if it's not given to you. If instead you're being given all of the sample data. So you have your sample mean. So let's say we have another example where we collected only sample information. Okay? Now if we only collect the sample information, then we're going to have our sample mean, we're going to have our sample standard deviation, and we're going to have our sample size. So let's say that we have data where the sample mean is 15, where the sample standard deviation, let's call it 6, and then we have a sample size of, let's say, 35. All right, and let's say that they ask you construct a 90% confidence interval around this data. All right, now notice that in this case we don't know sigma, so we cannot use this because we don't know sigma. Sigma, or our population standard deviation, is unknown. So what we're going to do is instead we're going to use an estimate using our t-tables. So we're going to do x bar plus or minus the t-value multiplied times s over square root of n. Now to find our t-value, we need to have our size of the confidence interval, and we need to use degrees of freedom of n minus 1. So we're going to do degrees of freedom equal to n minus 1, and we're going to have our confidence interval, which in this case is 90%. Now we need these to find the t-value that goes there. So what you're going to do to find this t-value is you're going to go into the t-distribution table. It's going to say t-distribution at the top. And then on the side, we're going to look for our degrees of freedom. The degrees of freedom in this case is n minus 1. Now because n is 35, then my degrees of freedom is going to be 35 minus 1, or 34. So I'm going to be looking for in the student t-distribution for number 34, which is in this case down here, on the first table for the t-distribution. Again, we're looking for 34 down here. And then we're going to look for 90% confidence interval. So you go to the top where it says 90%, and then you go down from that 90% all the way down to degrees of freedom of 34. And in this case, we have a t-value, 90%, degrees of freedom 34, of t-value is 1.691. 1.691. Okay, now that t-value, you're going to plug it into that t, and the rest of the information we have. So we're going to do our formula, x bar is 15. Then we're going to do plus or minus. Our t-value, which was found, is 1.691. And then we're going to multiply that times s, which is our sample standard deviation, and divide it by square root of n. N is 35, so square root of 35. If I was better, I could do this math in my head, but I can't. So here we go. 1.691 times 6. And then we divide that by square root of 35. So we got 15 plus or minus 1.71. Okay? This is our margin of error. That's our center of the data. And remember, a confidence interval is two numbers. We need to have a low value and a high value. So the answer is a low value, which is at 15 minus 1.71. So 15 minus 1.71. So I got 13.29. And then the high value is going to be 15 plus 1.71, or 16.71. And that is our confidence interval. Now again, what can you say with a confidence interval? Well, imagine that somebody asks you, what is the population mean? The answer is, I don't know, because I didn't collect population. I only collected a sample of 35 people. So I don't know where my population mean is. But I do know that I have my sample mean, and I am 90% confident. So you can say you're 90% confident that that mean is between 13.29 and 16.71. So my center of the data, my population mean, is between that number, and you are 90% confident of that. Alright? I hope you understand now how to do confidence intervals. Thank you for looking at Professor Choi's video, and have a good day.